So it's going to be a quick one. And I'd mostly just talk about the basics of Docker itself and how we can leverage Docker as a tool to build applications, right? I'm going to share my screen. I'll be sharing my entire screen and I'll be showing us some slides, right? And also trying to do some demo by the side. So I have a repository here. It's basically the same repository I've been using for a while. And I can share the link on the chat for whoever wants to try this out later on. You can just go ahead and make a copy or clone my own source code if that's what something else to do. I would send the link to the chat, and I think we can pick it up from there later on. So back to the slides. We're talking about Docker, right? And basically, Docker is known as a containerization technology that is used to build applications, right, so that we can easily run it anywhere. As a developer, you might have had to build applications in the past, for example, Python applications, um, Java, and all of that, right? And you would face a problem whereby most times it might work on a particular machine, but not work on others, or the configuration instructions might be different, right? So Docker is a technology that helps you aggregate all of the configuration, the code, and the dependencies together so that it can run anywhere, right? So the Docker container for a Java application would most likely work on both a Windows and Linux machine, right? So you can think of Docker as a container technology that helps you write once and run anywhere, right? Which is the concept of some of these languages like Java, but then you still have problems because the environments they're running on is different. But now when you bring Docker on top of those languages and those libraries and those tools, you're able to run your application typically anywhere, right? On any type of server. Um, Docker has been around for a while, and it currently supports, most of the operating systems you have. It supports Linux, supports Windows, and supports MacBook, right? And different other distros of operating systems we have. Um, and it's mostly, you probably see Docker holding a ship, right? Because it's meant to help you ship applications and bundle them together, right? And that's the keyword, like bundling applications together is like the keyword when it comes to Docker and containers. So the major thing about Docker is like how you write a Docker file, how you sort of effectively use Docker is by writing a Docker file, right? Um, Although in my slides they have a Node.js example and some code, I will be using a Python example and some code just to show you that you can use different languages with Docker and the configuration file typically looks the same. Now, at the end of the day, when you have a Docker file, it's meant to build and eventually run as a container, right? So you have an image that gets built from the file, and you have a container as the end result that you actually use, right, that you run. So on my screen here, if you can see my screen clearly, you'd see that I have few files, a Docker file, an index.html file, and a main.py file. The README is just a documentation file. So if I cut my Docker file, basically trying to show the content, it's very simple. And what it does is it pulls in a Python base image, Python 3.7, the stretch version. There are different types. You can pull in the major one, which is this. You can also pull in lighter ones like Alpine or Slim or Stretch. And what I'm doing next is to copy all the content of my file right into the app directory. Now, this might be different from your regular copy in Linux or in Windows. And this is mostly a Docker keyword, right? So Docker has its own keywords that, or let's say syntax that you use to write your Docker file, right? So yes, you're doing the same thing, but then it has its own special keywords that you should be familiar with. We'll see some of that in my slides. And I'm doing a bunch of other stuff, which will when I come back to this. So the Docker file builds a Docker image, and the Docker image gets executed as a container, right, which runs on your host machine, right, or wherever, even on the cloud. Um, so yeah, why do we use Docker containers and not VMs, right? It's much faster, right, to be able to build containers and not have to spin up VMs, virtual machines, all the time. And we'll see like more reasons in a bit. So this is what, on the left, you have a Docker container. On the right, you have a, typical virtual machine, right? So typically, a so on the left, this is like a virtual machine here rather, and this is Docker container. The virtual machine, your current OS would have to, if you look at the whole layer, right, the underlying um tool on your operating system itself in your virtual machine would most likely be, so if for example you want to run an application and you want to go and create an instance or a virtual machine instance on Google Cloud, on AWS, the host operating system is like the base stuff which you have to select when provisioning that virtual machine, right? The next thing is set up hypervisor. It has to install an operating system on that machine, right? It installs some libraries and then finally sets up the application. However, when you're using Docker containers, it's a bit different. You don't have to do all of these guys because Docker engine sort of abstracts away things like the OS and hypervisor, and it runs typically on an operating system. So all you need to bother about is just, your application and its dependencies, right? So Docker, multiple layers, as you can see here, and leaves figuring what the application and its dependencies will be, which is the libraries. Um, so Docker is basically a lightweight open source platform that allows you build applications, like we said, and run them anywhere. You can run Docker images on Linux, on Windows, even on Mac, right, wherever. Docker uses the concept of images and containers, right? Images are basically what's the um, artifacts that you get from running a Docker, from building a Docker file. Containers are what you get from running a Docker image, right? So containers are like instances of that image. You can have multiple containers of a single image, right? And the image is built from a Docker file. So basically this is how we build and ship Docker images, right? You typically build in a development environment. Most people these days build on a CI/CD tool like GitHub Actions, like Jenkins, right? There are other platforms where people build their images these days, and then they push it somewhere, which we'll talk about in a bit. And from there, so basically they store it somewhere, right? It can be a hub, or a registry, right? And eventually, when they want to use the image, they pull it from that place again, and they run it on different environments, right? You can run it on your local VMs or you can run it on the cloud, right? So you typically build in your development environment. It could be from your local, it could be from where you're committing your code to. So if you look at the example I have here, I am typically building this image from GitHub Actions here, as you can see, and I have a build and push action that builds my Docker image and pushes it to a container registry, right? If we look through these steps, you'd see that we are pushing this image to Docker Hub, right? If you want to sort of dig deeper into this, we're pushing it to Docker Hub eventually, and we're actually deploying the image to Google Cloud Run, which is where we want to deploy it to. So quite similarly here too, you can build on development environment or on your source repository or whatever tool you want to use. Store them in a hub or a registry. We're using Docker Hub in our case, and finally run them anywhere you want to run them, right? You can run them on the on people's machines or on the cloud itself. So sometimes, right, you might have heard me use some of these words. An image is basically the um artifact that comes out from running a Docker file, right? You build an image, right? So what you majorly focus on when you have a Docker file is you want to have a Docker image. And that Docker image is what gets stored on the registry or the hub, right? Which is the last point we have here. So this image is what comes out, and we're going to try to build an image very soon to see how that works. A container is a single instance of that image, right? Like I said, you have an image built from Docker file. A container is just a single instance of that image that's running. You can run multiple containers from a single image. Imagine a case where you have an application that has multiple users and you want to run the application plenty times so that you have high availability, right? Maybe you want to run the application in different environments because you want it to serve so much traffic. In that case, you can execute multiple instances of that image, and those guys will be called containers. Docker Engine itself is like the tool that runs Docker. It helps you do all the cool things you do with Docker, the building, the running, and all of that, right? And it can be set up, locally and also on your cloud platforms. The registry, which you have so many, you have Docker Hub. GitHub also has one, GitHub Container Registry. You have Google Container Registry. You have Elastic Container Registry, which is for AWS, right? So you can store your images in so many places and pull them whenever you need them. So these are some commands we'll probably play with. I'm going to try to build image and push it to. So I'm just going to share my screen again, my browser. I'm going to try to build this image from this repository, right? And I'm going to push it here. Currently I have these images, and I'm going to push a new one from this source code. So this is Docker file, like I'm currently showing on my terminal also, and I'll just run Docker commands to build, right? So the commands we have here, they're commands to pull images, they're commands to build. But let's try to pull an image first. There's a very popular image when you download Docker, and you want to test, they'll tell you to do Docker, maybe Docker pull hello world. Right, so let's try to pull that guy and see what happens. So because I don't have hello world on my laptop, it goes ahead to the registry and tries to pull hello world, and you can see now it has pulled hello world. It says pulling from library hello world, and if I do Docker images, you'd see that, okay, I have a bunch of images, but just right here, you'd see that I pulled in, I have the hello world image on my laptop now. So I'm going to just clear this screen and let's try something else. Now let's try to build our own image. If I say, so because we have a Docker file here, whenever I run the command docker build, it's going to use this file and build an image for us, right? So I can say docker build -c, my image, and -c here means the tag, right? What do you want to call this image you're building? Okay, I use builds, should be build. And finally, you need to put where you want to build, like what context do you want to build in. So if you have a special directory for your code base, some people use things like SRC for source. Different people use different convention, but because I have it on my root folder, all of the files I want to build are in this directory. As you can see, even my Docker file is also in the same directory which I'm in now. All I need to do is just put full stop, which means I want to build in the current directory and current context that I'm in. If I run this command now, it's going to try to build, right, which it's doing currently. So it's pulling in all the dependencies of the image, right? And I will show you that again on Git. So the first thing it does is so we have 6 instructions: pull the image, copy the contents, set the work directory, install a dependency flags, and then use Python to run main.py. So let's go through what it does too. So similarly, it runs 6 steps, you can see. The first step here is where it pulls in the base image. So it did that successfully here. It copied the contents of all of my file, which is also the same context I passed in, into /app, and it made /app the working directory. So whatever command I run would be run against this /app directory, which contains all of my source codes now. The next step, step 6, where I install Flask. Flask on its own has its dependencies. That's why you see that it's not just installing Flask, but it's installing so many other packages like zip, markup, save, Ginger for templating, and then finally Flask itself. So it's quite fine that a dependency also has other dependencies, right? So you can see that all of these logs are just for step 4 out of 6. In step 5, which is this, it really doesn't have to do anything at this point because this would mostly get used when I'm running the image, when I'm running a container, right? And then at the end of the day, because everything worked fine, it tells me you have successfully built your image. So I can do Docker images now. Let me grep so I don't show all of my long images that I have. My image, and you can see that I have an image called my image that was built just a minute ago, and it's quite heavy, right? 861 MB. But that's fine. Now let's try to push this image to a remote hub. So you can see people here building image, running container, and all of that. But I'm going to push it first before I start running it. So I can even delete it from my laptop and try to, I'm going to delete all my images and try to run an image I don't have, which is this one that I just built. So since I have it here, I can just say Docker. Now, if I want to push this image to Docker Hub, I need to make sure that I'm putting to my account, right? My own actual account on Docker Hub. So I can create a new repository using the same name I have locally, which is my image, right? So I'll go to Docker Hub, I'll type in my image here, and I'm going to leave it public because, okay, somebody has taken my image. Oh no, there's, okay, I had a space. So I'm going to just do create, right? And I have a public image now created. And you can see that there's no, I don't have any image yet. If you check tags, there's nothing available here yet. And that's because I don't have any image here. So Docker Hub is already giving me the commands to, use to push. They said if I want to push, I can just do Docker push here. But locally, remember that when I built, I used my image and I didn't put anything before my image, right? So I'm going to go and tag that image again so that I have a new image that has my username before my image. So I would say Docker tag my image and make it Simtech for you slash image. Right. Okay, no, let me say my image rather. Sorry. So now if I grab my image, you should see two images there. So you can see Simtech for you, my image, and then the initial one that I had. They're both the same thing. They have the same digest SHA, right? And they have like everything is the same, right? And now I can push this to the upstream, that's Docker Hub. So the tag for this is latest. You don't have to put a tag, you can just push directly. So if I try to push, it did not push because I'm not logged into Docker Hub yet. So I need to log into Docker Hub that lets you log in before you can push images. So I'll say Docker login. I'll put in my username and the password. And I think I should be logged in any moment from now. Yeah, so login successful. And now I can push that image. So I can say Docker push Timtech for you, my image. And it's pushing the image to, we can go back to be checking here. So currently there is no, I think, yeah, so it's still pushing. We can just wait a bit and let that finish through. I'm going to clear all the images on my laptop so that you can see that when I want to run it, it's going to pull it from the internet. So I can just go online and search for how to clean up images. Right? Because I want to show you how you can pull images from the internet. I'll use Stack Overflow because I prefer it. And this command shows you how you can stop all the containers, delete all images, and the next time you want to pull an image, you have to do it from the internet. So now if I run Docker images, you'd see that I have a long list of images, right? I'm going to go to Stack Overflow to copy one of their this command, right? This is going to, I believe, stop all the actively running images I have. There is nothing running, so that's why this shows this command. And what I can do next is to delete all of my images. So I'm going to just delete everything. So you can see it's deleted multiple images. And if I do Docker images, it should be reduced at least. So now I have just a few images. These ones are there because I think I'm active in them. for running Kubernetes locally. But now you can't find my image here anymore, right? So what happens now when I want to use the image I just built, right? The image I built from this Docker file. How do I do it? Docker is smart enough to know that when you want to build, when you want to run an image and you don't have it locally, it's going to pull it, right? So if you want to run a container of an image that you don't have locally, Docker is going to pull it in, which is the one of the commands you have here, that says, Docker container run. A shorter syntax is Docker run, and just passing the ports and passing name of the image. So I want to check the ports of this application. The application I have runs on ports 8080 by default if no port was passed. So I'm just going to say Docker container run, right? I'm going to copy the syntax they have here. -d means run in the background, like run as a daemon. -p is the port, so I want it to run on 8080 on my laptop and also forward to 8080 within the container, right? So I'm port forwarding 8080, 8080. And then the name of the image or the name of the container. So I can say my container, right? And then finally, the image you want to run. So the image I want to run is, I can just go back to Docker Hub. Please tell me if I'm scrolling too fast. Now you see that it has been pushed. Although I've already deleted this from my laptop, it has already been pushed here, right? You can see it here. I don't need the full command, so I'm just going to paste this here and strip off a part that I need, which is this one. Yeah, I don't say I can just put the image tag, right? So this is the full command you want to pull an image, and any of us can try this out on their laptops. Just to confirm that, because it's a public image, everybody should be able to pull it. So I'm pasting this here and I'm going to run it. So Docker container run, -d run as a daemon that's in the background, port forward 8080 to 8080 within the container. What my application, make this container, make it, name it as my container, right? And like I said earlier, is basically an instance of an image, right? So I'm calling this instance of this image I want to run my container as the name, and I'm saying pull this container, sorry, pull this image, right? This image is not on my laptop at the moment, but Docker is smart enough to go to Docker Hub and pull it from my account. So I'm just going to hit enter here and let's see what happens. You can see the first line says unable to find this image locally, but it's pulling it from the internet, right? And it's going to pull like the entire image over to my laptop. Last time I ran Docker images, you couldn't find it on the list because I've deleted it off. After this is done, if I run Docker images, you would see it there. Alternatively, I can open images here for you, and you'd see that on my Docker desktop, it's not part of the images I have yet. There is no container running currently, but once this process is done, two things would happen. Number one is going to bring in that remote image from Docker Hub to my list of images. And because I'm using a Docker run command, it's going to add a new container here. So let's just wait for this guy to finish and we can confirm. It would be nice to drop questions if you have any on the chat while this is going on. So I've showed you an example of a Docker file from the one we had. Ours is a Python, has a Python-based image and very similar stuff. We are copying the content of our folder into the Docker workspace. And finally, we are sort of running a Python script using Python as the entry point, right? But you can, for every language, you have a different set of instructions because things like Node.js or React would use NPM. Things like Python would use Python, of course. Languages like Java would use maybe Gradle as their entry points, right? Yeah, and so many other languages have their own tool. I'd not get into this today. I'd mostly just stop on what a Docker file would look like. It would be nice for us to try to come up with a Docker file ourselves and build them and push to um, a public Docker registry, right? And then maybe just deploy it to the cloud if possible. So I'm going to go back to my container now. It's done pulling, and this ID here is like the ID of the container that is running currently, right? If I do Docker PS, it's going to show me the list of containers, and you can see that the first few um ID, right, matches what you get as the outputs of the previous command that I ran. So that means this is running. The name of the images, let me just make it smaller so you can see everything in one screen. The name of the image I'm running is my image, teamtech for you / my image, which is what I pushed earlier. And when I check images here, you can see that I now have that image. It was pulled in some minutes ago, right? The next thing here is the command, which is from my Docker file, python main.py, right? That's what my image is running. It was created, this container was created, this instance was created 46 seconds ago. It has been up since then. It has not crashed yet. And it's port forwarding 8080 to 8080. And the name of this container is my container. I can do the same thing again, right? But now call it my container 2 and also change the ports, right? So I would say 8082. And just because I want to run another instance of that image. Now, if I do Docker PS, you'd see two different containers running the same image, right? One is port forwarding 8082 on this laptop to 8080 internally. The other is port forwarding 8080 to 8080, right? So you can't reuse the same port on your host machine. You have to change it, or else Docker is going to fail. But you can always point to the same port within the container, right? Um, some cool things people do when they have multiple containers of the same image running is that they do some load balancing. So imagine you have an application that has so many traffic, you can run multiple instances of that container, which is quite all right. And you can use web servers like Nginx to send traffic to each of these containers one at a time. So it means if you have multiple containers, you're able to split traffic within them, even on the same server, using something like a web server, right? Nginx, Apache, or Kadi. Those guys are smart enough to take all of the addresses of all the containers you have and send traffic to them, right? In a way that none of the containers are overwhelmed, right? They probably do some load balancing whereby they send traffic based on how free that container is. So if this is accepting traffic currently, Nginx would know that the next person should be this guy, right? And you can keep running multiple containers and giving Nginx the list of the IP for each of them so that it knows that it can send traffic to this container. And that's something Kubernetes does, which we'll probably look into before the end of the program. So let's go back to my browser now and test these two ports. So I have localhost 8082 and localhost 8080. I'll just do localhost 8080 and you can see that it's working. If I open another tab and I do 8082, you tell that is also working, right? If I try a wrong port, 8081, it's not going to go because there's nothing running on it. I can spin up another instance of this container and I'll just do that. So I'll go back here, run the same command, change the container name to maybe my container 0 and change the host IP, the host port to 8081. If I go back to my browser now, I can refresh and you see that it's up, right? So I have 3 instances of that image running, each of them running on different ports, right? You have one running on 8080, 8081, and 8082. Now, if you notice something for these last 2, they did not have to pull the images from Docker registry anymore, because I already have the image on my laptop. So once you have the image, it's easier to just run it. It doesn't have to pull from the internet again. But if you don't have the image, it has to pull it from the internet every time, right? Um, So yeah, I can go back to my Docker desktop to just give you a more better visual of what I have running. I have 3 containers running, right, of the same image. You can see the image is the same, but the container name are different. Their IDs are also different. They are running on different ports on the host machine, but they're all port forwarding to the same ports, right, within the container. They started different time ago. You can use some Docker commands to stop them, right? Or you can also stop them from the UI. So yeah, and I can send this image to anybody to run, and the person doesn't have to deal with installing Flask and copy code locally, but he just needs to run this image, and he can access the application I built. Yeah, so that's mostly all. Okay, I think this is something I most times confuse myself, CMD and entry points. I think, yeah, so entry points cannot be written, as they said here. But CMD, most times people use CMD when you can always change CMD from your run command. I think I've done this very frequently in Kubernetes where you are changing the command that is running, right? So I'll give you an example. I can run this if I have another Python file within this particular repository. The entry point would not change. It's still going to remain Python. So that means like the first thing that the container will do is to run Python, right? And then run it against whatever is passed as your CMD. This is like a variable. Just take it as a variable in this case, whereby you can easily overwrite this even when you're running your container, right? And a visual example is going to be this. If I come here, click on images, and click on this image, and I say that, okay, I want to run, let me just click on this image here and say I want to run a container, right? Run a new container. If you look down here, it tells you that you can pass in, where is it? There's a place to pass in the CMD you want to override with. Usually you can override. Just that's right. So you can pass in custom arguments that you want to run, that you want to pass to your Docker run. So usually, in this example here, they are using CMD to run CMD bash to run this script. You can change it to do something else, Charlie, right? So like I was saying here, if I don't want to run this main.py and I want to run a different file, I can pass it during the run phase. Quite similarly here, they can also put in some extra arguments, and that would be their CMD instead of using the default one, right? So if this person wants to run a different file, or he wants to pass another argument, right, to his one command, you can just totally pass that during the Docker run phase and not have to rely on what was initially defined within the code. I believe the entry point does not change, right? So if you want to make sure that, okay, this image always runs Python, but then the users are able to pass in whatever file they want to run against, then you can use a CMD, right, to change that dynamically. So you don't have to build a new image, because if everything was hard-coded in the entry point, then it means you have to change the Docker file. But then if you have this CMD, letting them select what file they want to run, they can easily override that during the run phase. Yeah, so I'll share a cheat sheet for Docker on the group, so we can just look through the commands. There are quite a bunch of commands to get familiar with. This just showed quite some basics, but there are quite a lot, right? But so far we have been able to like build and push and then pull images that did not exist on the machine. We also deleted like a bunch of images using RMI. And we did some tagging too, right? We're able to tag images and push them again to Docker registry. Yeah, so I don't know if we have other questions. Okay, I'm going to stop here if you don't have any
Thank you.
questions.
Thank you very much, Tim, for that enlightening and interesting session. So I think we have a comment. My Francis in the chat box. He asked a question over there.
Oh yes, I mean I think I just took that. It was part of my final.
Okay.
Yeah.
Okay, great then. So, I don't know. Is there any other question from Francis or Margaret? Okay, it's now brain box. Okay, Margaret's network is punctuating, I guess. Okay, I guess we have nothing. Okay, thank you, brain box. Um, so I think we can just round up. Tim, do you have any last pointers for us before we call it a day?
Okay, yes, so I have this resource that's quite helpful because Docker is a tool that has like a lot of commands. Um, there's usually the CLI cheat sheet that will be really helpful for everyone. I'm going to just share my screen. And I'll send link to the charts too. So this is it. There are quite a lot of commands to get familiar with, right? First off, you'd want to install Docker on your laptop. And you want to get familiar with different commands for doing stuff, right? Commands that are particular to images, building and pushing. Commands that are particular to containers. So I'm currently running a container, right? Running multiple containers. And there are things you can do against these containers, right? You can check their logs. You can connect to them using exec, I believe. Yeah,
Mhm.
you can inspect them and debug them, like do so many things. And it'd be nice to get familiar with most of these commands. I think they covered most things we did today. And then yeah, the basic one, right? It's login and push, login to Docker and push. So it'd be nice to create an account and you'll be able to push one image to a private repository and other images to a public repository, right? Except you want to pay Docker Hub. But yeah, it's really good to get familiar with these container commands. They are really helpful when debugging. And I think, I've sent link to the chats. I think we'll share it on WhatsApp too, so that people can take a look at it. Yeah, I think that's all.
Okay. I think the cheat sheet is actually really extensive, so probably look at it to myself. Thank you so much, Tim, for that. And I guess if we don't have any questions from anyone, we can just call it a day.